what we are doing for the different clusters. So here we performed each and every step. After performing each and every step, what we are doing, we are observing the plot. So here if you observe this graph, so here for the cluster 1, so for the cluster 0 we kept red color, and for the cluster 1 we kept blue color. So here it is cluster 1, and for cluster 2 we kept some different colors. So here these are the different colors. Cluster 1 corresponding to this green color, and blue color correspond to cluster 2, and green color correspond to cluster 3, and this what is this color name? Cyan. So here this cyan color represent cluster 4, and this pink color, that is nothing but magneta, corresponds to cluster 5. And here we kept centroids with orange color with 300 magnitude size. So here these are the different clusters. Based on these clusters, so based on these categories, we need to judge which person belongs to which category. We need to give some names to these categories. How to give names? So here initially we have cluster 1. So if you observe this cluster 1 people, they are having good salary. That is nothing but they are having salary in between 40 to 60 kilo dollars. So here 40 to 60 kilo dollar salary they are having, and they are spending 40 to 60% of their amount only. So they are spending 40 to 60% of their amount only, and they are saving remaining money. That means they are very careful people. So here I want to give cluster 1 name as label as careful people. And after that, if you observe the cluster color blue, so the people who are having color blue, so here it is color blue. So these are which kind of people? So they are having very good salary, and they are spending very low amount. So here they are having very good salary, and they are spending very less amount. So such kind of people said as careful people actually. So here I want to say this kind of people as careful people. And I want to say this kind of people are standard people. They are getting optimum amount of salary, and they are spending optimum amount of salary on the shopping mall. So here they are getting optimum amount of salary, and they are spending optimum amount of money in the shopping mall. Whereas coming to these people, they are getting huge amount of salary, and they are spending very less amount of money in the shopping mall. That's why I'm keeping name as they are very careful people. So after that we have one more category, that is green color people. So here green color people getting very less salary, and they are spending optimum amount of money only. So whatever the amount they are getting, on that amount only they are spending little bit amount. So for that people I am keeping as target people. So here I need to focus, or I need to target these peoples. I need to provide offers to this kind of peoples. That's why here I'm saying target category. So after that, here for the next category, cyan color, which is nothing but this color. So here these people getting 20 to 40 kilo dollars of salary, and they are spending huge amount of money on the shopping mall. They are earning less, and they are spending more on the shopping mall. That's why here I'm giving their category name as careless people. So here I'm saying this category as careless people. After that, I want to give the name for this category also. Again, they are getting good amount of salary, and they are spending good amount of money in the shopping mall. That's why I will say such kind of people as sensible people. So here, whatever the names you want to give based on observing this data. So whatever the performance you observed based on this data, you can give that names. So here I kept this names randomly. I want to modify the cluster names. So here it is about this thing. After that, everything is same only. So here cluster 1, sorry, these are the cluster names, and it is corresponding to x-axis, and it is corresponding to y-axis. I am running this portion. So whenever you run this portion, here we replace it all these category names. These are the standard people, and these are the very careful people, and these are the targeted people. We need to provide some offers to this kind of people. After that, these are the careless people. They are getting very less amount of money, and they are spending huge amount of money on the shopping mall itself. After that, sensible people. They are getting good salary, and they are spending good amount on the shopping mall. That's why I'm saying those people as sensible people. After that, these are the different centroids. It is about k-means clustering algorithm. So now I will take one more session. In this session, we will discuss hierarchical clustering algorithm, so that you can easily compare both the things.
Hello and welcome back to the course on machine learning. And in this section, we're kicking off like we looked at previously. This is a two-dimensional space. If you apply hierarchical clustering, or let's just say HC for short, what will happen is you will get clusters, again, very, very similar to k-means. In fact, sometimes often the results can be exactly the same as k-means clustering. But the whole process is a bit different. So let's talk about it in a bit more detail. So the first thing that we need to note is that there's two types of hierarchical clustering: agglomerative and divisive. So agglomerative is the bottom-up approach, and you'll see in more detail just now what that means. So we'll be starting at the very bottom and then building our way up. Divisive is the opposite, starting at the top and dividing the clusters into multiple. In this course, we'll be focusing on the agglomerative approach. The divisive, we'll mention it a bit just now when we're talking about the agglomerative, but it's basically the same thing, but the other way around. It's the reverse of the agglomerative. And if you like, you can definitely research more about the divisive approach, but for now we're going to focus on the agglomerative one. Alright, so the agglomerative hierarchical clustering. How does it work? Well, to start off, we're going to break it down into a step-by-step approach, and then we'll look at an example and manually perform the clustering. Alright, so step one in HC is to make each data point a single point cluster. So that forms n clusters. So if you have n data points, your first step is to look at each one of them as an individual cluster. Then step two is to take the two closest data points and make them one cluster. So to combine them into one cluster, and that forms n-1 clusters. Then step three is to take the two closest clusters out of the ones now that you now have and make them one cluster. That forms n-2 clusters. Then step four is to repeat step three until there is only one cluster. So basically you just keep repeating step three and combining points into bigger and bigger and bigger clusters until there's only one huge cluster left. So you just keep repeating step three, and at the end you're done. So at the end you'll have one huge cluster left. And how to get from 1 to 2 or 3 clusters, how to get the final result that you actually want, we'll talk about that in this section as well. So that's the goal, of course. But one thing that stands out here is the words closest clusters. Now, we've already talked about distances, and we mentioned Euclid, that you can use Euclidean distances or other distances, and that's totally fine when you're working with individual points. But here we're actually going a step even further, and we're talking about not just the proximity of points, but actually proximity of clusters. And this is something worth noting. So I'd like to pause here for a bit or like kind of step to the side and talk about the closeness of clusters and how you measure distance between clusters, because that can really affect your algorithm if you're using hierarchical clustering. So let's talk about that for a few minutes. So first of all, Euclidean distance, just to get this out of the way once and for all, Euclidean distance is in a two-dimensional space. It's calculated like that. So the distance, if you got 2 points, P1 with the coordinates x1 and y1, P2 with coordinates x2 and y2, then Euclidean distance, or the length of this line, is calculated as x2 minus x1, so that the distance between the x's squared plus the distance between the y's squared. So basically, and then you add them up and then you take the square root. So basically it's you've got a right angle triangle over here, and you've got the catet here, and you got another one catet here. I hope I'm pronouncing this right. And then this is the hypotenuse, right? So that is how you calculate the distance between the 2 points. So it's basic geometry back from high school, and there you go. That's just how Euclidean distances are calculated, and that's what we're going to be working with. But again, there are other types of distances that you could be invoking in your algorithms, and it really depends on the scenario and how your algorithm is going to be structured. But in our examples, we're going to be working with Euclidean distances because they're the more natural type of distance. And now let's talk about the distance between two clusters. So let's say you have two clusters, the red and the blue. How do you measure the distance between them? What is the definition of the distance between two clusters? It's not as obvious as it might sound at the start, because there can be a couple options. For instance, you can option one is just take the two closest points and measure that and call that the distance between the two clusters. Option two is actually take the two furthest points and call that the distance between two clusters. That's also a valid approach. Option three, take the average. So take the average of all the distances between the different points in the cluster, so all the combinations of different points, and take the average of that distance. Option 4 is take the distance between the centroids. So find the centroids and find the distance between the centroids and call that the distance between the two clusters. So it's a very important part of hierarchical clustering, what you define as the distance between two clusters, because that can significantly impact the output of your algorithm. Now, we're not going to delve much deeper into this. It's just something to remember, to note, and based on your particular situation, whether it's a business problem or other type of data science problem, based on what exactly you think is the best approach, you're going to need to define that in your algorithm. So just keep that in mind, that for the hierarchical clustering algorithm, the distance between clusters is a crucial element, and you need to remember what exactly you're setting at. You're setting it to be, how you're defining it in your approach. All right, so we talked about that. Now let's move back to our example. So we've already looked at the step-by-step rules, and I'm a big fan of a step-by-step approach. Now we have that step-by-step approach, and it might have seemed a bit overwhelming, as always, because we didn't have an example, but now we're going to have that example, and we're going to look at how to build those hierarchical clusters. So step 1. Make each data point a single point cluster. That forms a 6 clusters. Let's have a look at that. You can see every single point is a separate cluster. Next, take the 2 closest data points and make them one cluster. We can see that these 2 points are the closest, so we're putting them together in one cluster. Now we have, so out of the clusters we had, because remember each point out of these 4 has the minimum distance. So that would be the distance between the clusters. Our algorithm, that's how we've only got 2 clusters left, so the last step would be to combine them because they are by default going to be the closest. So there we go, and so that is the end of our algorithm. That's how it converges. We've gone through the process of going from all points seen as an individual cluster, so each point is an individual cluster, to now we only have one cluster that combines all of the points. And so what's the
So I will forward the link in the group. So try to join in the group within 2 to 3 minutes.